Alright, just start whenever you're ready.
Alright, hi, I'm Destiny Tignon, and today my presentation is about applying a polynomial curve to our solar system to see how to get the best fit line as to our planets. Alright, so this data we collected from NASA, it shows the 8 different planets and the mean distance they are from the Earth, or from the planet to the Sun. The units are astronomical units, so Earth has 1, which is the planet that we're on, and then the farthest is Neptune at 30.087 astronomical units, and Mercury is the closest with 0.387 astronomical units. So from this data, we constructed a line to try and fit all of the points to it as best as we can, and we got the line P of x equals 0.4515x squared plus 0.6119x minus 0.0634. So when we graph that line, we see our points in blue circles and the line of that graph going up in orange. And we can see that at the first part of the line, all the points are on it for the most part. And then as we get farther out with the farther away planets, we start to see that the line falls nowhere near the curve of all of our planets. So this is a MATLAB code for that graph. The distance is how far away all of the planets are from the sun, and the period is how long it takes for them to orbit around the sun. And then we set those into a table, plotted those to have each individual point to see how well they would fall. And then we, in a separate line, we put in the actual equation that was found earlier. And so this table is again showing the data that we collected from NASA for the mean distance and for the period. However, it was thought that by taking the natural logarithm, we would have a better fitting curve to all of our points as opposed to just taking the mean distance and the period. So once the natural logarithm was taken for both the mean distance and then as well for the period, we found that there was about a 3:2 ratio between the natural logarithm of the mean and the natural logarithm of the period. And from that, we constructed the MATLAB code for all of the planets, and as you can see, all of the points line directly onto that line. So we know that this one is fitting it much better than our original thought of doing a quadratic formula as opposed to doing the natural logarithmic. And so this is the code for the previous graph, and as you can see, for the most part, it's fairly similar to what we had earlier. However, now we're using the polyfit, which is a code specific that's in MATLAB. That's a program that it has within it. And so that's taking the best fit line for our actual data points. And so now here's both of the lines graphed in Scientific Notebook. The lighter gray line on the bottom is showing the ones that actually fit towards our points, and the black line going along the top is our initial quadratic formula. And that's it.
Alright, so my project was applying the polynomial curve to Pluto, and probably the most difficult part of the project was actually getting the numbers. NASA had about maybe 3 or 2 planets with information on their website, which I find very misleading because they should have all of the information. But after looking at their measurements and looking at how far away the moons were actually from Pluto, I had to use those measurements to figure out the rest of the table. And by looking at Destiny's table, which basically made Earth, the center planet, a 1-to-1, that way it was the main point, I used that same method with the moons, using Nix, the middle moon, as my measurement for the rest. And so using how far it was from Pluto, I divided all of the rest of the measurements, which gave me the mean distance. And then in order to find the period, 1 day in Pluto is 6.4 Earth days. And so I basically divided all of the Earth days given to the Pluto moons by Earth days in order to get Pluto days, which is the period or my y on my table. And then in order to get the natural log of the mean and the natural log of the period, I simply plug them into Scientific Notebook in order to get the results for my table. And as you can see, the top table has both mean distance and natural log of the mean distance, and then period and natural log of the period. So for my first graph, I basically plugged in the quadratic formula that I got, which was p of x equals 0.2774 x squared plus 0.86039x minus 0.13779. And although I'm pretty sure it is hard to see the small dots, since a Scientific Notebook really can't do them any bigger, we can see that under the line there is a very tiny yellow dot, which would be Sharon, and I hope I'm saying these moons' names right. And then Styx is pretty much basically on the line. Nyx is kind of slightly above, but mostly in the line. Kerberos is above the line, and then Hydra is the one that we can see above the blue plane. And then the second try was one that it gave a better fit, and when drawing it or having Scientific Notebook draw it in 2D, it actually makes it seem like all of the moons are actually on the line. But I wanted to draw it in 3D just to see how it actually looked. And as I found out, the moons don't actually all cross that line. Sharon is still under. Styx is slightly under compared to the last graph, but it seems to be on the line. Nyx is right in the middle, and then Kerberos and Hydra are above the line, but they're not as far as they were in the graph before. And using MATLAB, the best fit line in MATLAB, it actually created a line, and I for some reason wanted it just to be straight, but because it is not a set ratio for all of them like it was in the solar system where it's a 3:2 ratio, only Sharon, Nyx, and Hydra have a 3:1 ratio, whereas Styx and Kerberos have a random ratio of 1.4 and 1.3, which does not allow me to have a complete straight line like how I wish it could be. And this next graph, it's a solar system best fit line with Pluto's moons, and so what we did is we used my points that I got, and we used Destiny's line of best fit to show how it actually looked. And I'm not surprised that they're not the same, because once again the ratios are not equal at all, but you can see that Pluto's moons do not fall at all within the solar system's best fit line, which is why it's important that I actually got my points a different way than just using the measurements that I was originally given, just because it shows that Pluto's moons are not at all within the same ratio as the planets from the sun. And then the MATLAB codes, on the left, it's Pluto's best fit line, and just like Destiny's MATLAB codes, the first one is distance, which is basically x, and the period, which is how many times the moons go around Pluto, and these are counted in Pluto days, not in Earth days. And then we go through doing t equals table of distance and period, plotting it, and then it created the graph. And on the right side we have the solar system best fit line with Pluto's points, and the top portion is basically my code for the points, and then the second part of the code is Destiny's data for her best fit line, and then at the bottom we just added so that it could create the polyfit, and it could create all of the pictures, and then we plotted it and we were done. And that is our project about Pluto and its moons in the solar system.